Imagine being lost in the wilderness, the sun dipping below the horizon. The air grows cold and fear starts to creep in. Then you see it, a flicker of light dancing in the distance. As you approach, the warmth of a crackling fire embraces you, offering comfort and safety. This primal force, fire, represents not just survival, but a connection to something ancient and powerful, a beacon of hope in the darkness. Fire is a force we often take for granted, yet its existence is something truly special, almost exclusive to our planet Earth. It requires a delicate balance of oxygen, fuel, and heat, conditions that are rare in the universe. What exactly is fire? This mesmerizing and sometimes terrifying phenomenon that has fascinated humans for millennia. And why is it so rare beyond Earth in the vast expanse of our solar system and beyond? Fire isn't an object itself, but a process, a chemical reaction that we often take for granted in our daily lives. Scientists call this process combustion, a term that encompasses the rapid oxidation of materials. Think of it like baking a cake. You need the right ingredients in the right amounts, mixed together under the right conditions. For fire, these ingredients are represented by the fire triangle: fuel, heat, and oxygen. Each element plays a crucial role in the creation and maintenance of fire. Fuel can be anything that burns wood, which has been used for centuries to provide warmth and cook food; paper, which ignites quickly and is often used to start fires; and even certain metals, which can burn at extremely high temperatures. Heat provides the energy to start and sustain the fire. Without sufficient heat, the fuel cannot reach the ignition temperature needed to combust. Oxygen, readily available in the air we breathe, acts as the key ingredient that allows the fire to burn. It supports the chemical reactions that release heat and light. Remove any one of these elements and the fire is extinguished. This is why fire extinguishers work by either cooling the fire, cutting off the oxygen supply, or removing the fuel source. Firefighters are trained to understand the fire triangle and use this knowledge to effectively combat fires, ensuring safety and preventing damage. From the dawn of humanity, fire has been a vital tool, providing warmth, protection, and a means to cook food. Understanding the fire triangle helps us harness this powerful force safely. Today, we use fire in countless ways, from industrial processes to controlled burns in agriculture. The principles of the fire triangle remain the same, guiding us in both creating and controlling fire. So the next time you light a candle or sit by a campfire, remember the fire triangle and the delicate balance of elements that make it all possible. Earth's atmosphere is unique in our solar system. It possesses the perfect blend of ingredients to make fire possible. Our air is composed of roughly 21% oxygen, a surprisingly high concentration compared to other planets. This abundance of oxygen, combined with a nitrogen-rich atmosphere that doesn't extinguish flames as easily as other gases, creates an ideal environment for fire to thrive. Without this precise mix, fire as we know it would be nearly impossible to sustain. Other planets lack this crucial combination, making Earth truly special in its ability to support fire. Let's take a closer look at our planetary neighbors. Earth, with its perfect balance of oxygen and nitrogen, effortlessly supports life and combustion. But what about Mars and Venus? Mars, often hailed as a potential second home for humanity, has an incredibly thin atmosphere composed mostly of carbon dioxide. This thin atmosphere means the planet struggles to retain heat, resulting in frigid temperatures. Additionally, the absence of a magnetic field leaves the surface vulnerable to harmful solar radiation. While carbon dioxide can support some forms of combustion, the lack of sufficient oxygen makes starting and sustaining a fire nearly impossible. Fire, as we know it on Earth, relies heavily on oxygen to ignite and burn. Without it, even the most basic survival tasks become daunting. Venus, on the other hand, has an extremely dense atmosphere, almost 100 times thicker than Earth's. This thick atmosphere is primarily composed of carbon dioxide, with clouds of sulfuric acid, creating a runaway greenhouse effect that traps immense heat. Although Venus technically has more oxygen than Mars, it's chemically bound with other elements, making it unavailable for combustion. The oxygen is locked in carbon dioxide and sulfuric acid, rendering it useless for fire. The intense pressure and scorching temperatures on Venus would also make any potential fire incredibly difficult to control. The surface temperature is hot enough to melt lead, and the atmospheric pressure is equivalent to being 900 meters underwater on Earth. These extreme conditions make Venus an inhospitable environment for fire and human life. In stark contrast, Earth's atmosphere, with its 21% oxygen, supports not only fire but also a diverse range of life forms. Fire has been a crucial element in human development, from cooking food to providing warmth and protection. It's a testament to how unique and perfectly balanced our home planet is. So while Mars and Venus offer fascinating insights into planetary science, they fall short as potential homes for humanity. Their atmospheres and environmental conditions are far too extreme and unsuitable for sustaining life as we know it. Earth remains our only haven in the vastness of space. Fueling the flames, Earth's abundant combustibles. Beyond the atmospheric advantage, Earth boasts an incredible variety of fuel sources that are essential for fire. From the sprawling forests teeming with life to the dry grasslands swaying in the wind, our planet is a treasure trove of combustible materials. This vast abundance of flammable material, combined with our oxygen-rich atmosphere, transforms Earth into a veritable tinderbox, starkly contrasting with the barren, lifeless terrains of other planets. Fire up close, a dance of atoms and energy. At its core, fire is a mesmerizing dance of atoms and energy, a spectacle of nature's raw power. When a material heats up, its molecules begin to move faster, colliding more frequently and with greater force. This heightened activity causes the bonds holding the molecules together to break apart, releasing energy in the form of intense heat and radiant light. In the presence of oxygen, these freed atoms then bond with oxygen atoms, forming new molecules like carbon dioxide and water vapor. This continuous process of breaking and forming bonds releases even more energy, fueling the chain reaction that manifests as the flames we see dancing before us. Is fire a plasma? The ongoing scientific debate. Interestingly, there's an ongoing scientific debate about whether fire truly qualifies as a plasma. Let's dive deeper into this fascinating topic. Plasma, often considered the fourth state of matter, is a gas that carries an electrical charge. It's found in lightning, stars, and even neon signs. While fire does contain some ionized particles, which would classify it as a partial plasma, it doesn't exhibit all the properties of a full plasma. Scientists are still analyzing data and conducting experiments to determine if fire meets all the criteria to be considered a true plasma. The debate continues, making it an exciting area of research. Fire's cosmic rarity, a uniquely earthly phenomenon. The unique combination of factors present on Earth, an oxygen-rich atmosphere, abundant fuel sources, and a suitable temperature range makes fire a rare phenomenon in the cosmos. While scientists believe that certain types of combustion might occur in the extreme environments of stars or gas giants, these processes are vastly different from the familiar fire we experience on Earth. Earth's atmosphere, rich in oxygen, is a key ingredient for fire, unlike the thin or toxic atmospheres of other planets. Additionally, the planet's diverse fuel sources, from forests to fossil fuels, provide the necessary material for combustion. And Earth's moderate temperature range ensures that these materials can ignite and sustain a flame. This unique blend of conditions makes fire a truly earthly phenomenon, rarely replicated elsewhere in the universe. Fire and humanity, a billion-year bond. From the moment early humans first harnessed its power, fire has been an integral part of our story. It's more than just a tool, it's a symbol of survival, innovation, and community. Fire's rarity in the universe only amplifies its significance to humanity. In the vast expanse of space where cold and darkness reign, fire stands out as a beacon of warmth and light. It's a phenomenon that's not just rare, but almost miraculous. For over 1 million years, fire has shaped our evolution, providing warmth, protection, and the ability to cook food. It allowed our ancestors to venture into colder climates, to fend off predators, and to gather around in social groups, fostering communication and culture. It's been the cornerstone of countless technologies and continues to power our modern world. From the steam engines of the Industrial Revolution to the power plants that light up our cities, fire's transformative energy has driven human progress. The next time you see a flickering candle or a roaring bonfire, Take a moment to appreciate the intricate cosmic dance that makes this seemingly simple phenomenon possible. It's a dance that involves the delicate balance of elements, the right conditions, and the spark of life itself. Fire, a force we often take for granted, is a testament to the unique and precious nature of our planet Earth. It's a reminder of our connection to the cosmos and the fragile beauty of our existence. As we look to the future, let's remember the billion-year bond we share with fire and continue to respect and harness its power wisely.